Alright, today's notes are going to be on factoring using greatest common factors. And so I can have enough time for examples and stuff. I'm going to go ahead and jump straight in. Alright, what I want you to do is pause right now. Well, after I get to talking. Pause and work number 1 and number 2. Do what the instructions tell you to do. Go ahead and pause them and then see if you get the same answer as I do as I start working them out. Alright. Are you paused? Did you pause? Did you pause? Did you pause? Alright, here we go. Number 1 should be 3x minus 15. And number 2 should be negative 24 x to the 4th y to the 7th plus 12x cubed y. Now, how did I get those? I did the distributive property. Okay, all this times all your terms there. Today what we're all doing is actually starting here with problems like this and working our way back to the original problem. Okay, we're trying to find the two pieces that multiply together to give me this big thing, which those are. The two pieces that multiply together to give me this, which 3 and x minus 5 is. And so let's first go into the definition of a greatest common factor. The greatest common factor, the definition is the product means multiply, or the answer for multiplication, of the greatest integer and the greatest power of each variable that divides evenly into each term. So what that says is give me the most of everything that you can out of each term that you have. That's all it's asking for. The biggest number, that's why it says positive or negative number. Give me the biggest variable that I can take out of each term. Here's the steps. How to factor. Find the greatest common factor, the number or variable or both that's in every term. So don't think that the greatest common factor is always going to be a number or a variable or both of them. It could be either or. It can be a number, it could be a variable, or it can be a combination of both. Now this stands for greatest common factor. Write the greatest common factor next to a set of empty parentheses and divide each term by the greatest common factor, and the answer goes inside the parentheses. So how do you figure out what goes inside the parentheses? Divide each of your original problem's terms by your greatest common factor. So that took about 2 minutes and 45 seconds. Let's actually work some examples here to see if we can understand the greatest common factor. Looking at number 2. The first thing I have to do is figure out the numbers. So always start with your coefficients. What's the greatest number that I can take out of both of those? Hopefully that you see it's a 5. Now look at my a's. I have an a to the first power in each one of those. So I can take out an a. And m and n. Notice I don't have an m and an n in each one of these, so I cannot take out an m and an n. So as it turns out, 5a is my greatest common factor. So step number 2 says write that next to a set of empty parentheses. Okay. I usually make them big enough to fit something in. I don't know what's going to go in there most of the time. So I'll make it big enough. Now, how do I figure out what's going in here? Well, if I divide or take away a 5a, you get an m. If I divide or take away a 5a, which is what's out here, you get a minus n. But say you didn't get that. Let me show you real quick. If I take my original, this is step number 3, divide each term, talking about each one of those, by your greatest common factor. My greatest common factor is 5a. So I divided by 5a, those cancel out, and all that's left is an m. If I divide negative 5an by 5a, which is my greatest common factor, notice that the a's cancel out and the 5's cancel out, so all I have is negative n. So that's what goes right there. This is the two things, this 5a and m minus n in parentheses are the two things that multiply together to give me this statement here. So these two are factors. So if I ever ask you to factor, always look for a greatest common factor first. That's what you always look for. There won't always be one, but you always look for one. Moving on to number 2. Number 2, I'm looking for a greatest common factor. Notice on number 2 I have 3 terms. That's no issue. The idea is, let's look at the numbers first. I have 2, negative 4, and 6. What is the biggest number that's in all 3 of those? As a multiple or as a factor, the answer is 2. Okay? Yes, there's 2 2's here. Yes, there's 2 times 3 here. but there's at least a2 in each one of those. Now look at your variables, your coefficients, your variables and their exponents. What's the most number of c's that you can take out of each one of these? The answer is 2 of them. This one has 4, this one has 3, this one has 2. So c squared. So here's a hint, guys. Whenever you're trying to factor out using the greatest common factor, you're dealing with your variables and exponents, always pick the one to factor out that has the smallest number of exponents. Think about it, it makes sense. The smallest number is going to be in every single one of them. So in this case, the smallest number of exponents is c squared. So once you have that, you write that next to an empty set of parentheses. All right? And so now if I divide 2c to the fourth by 2c squared, I'm going to have c squared left over. How did I get that? If I take 2c to the fourth and divide it by 2c squared, those cancel out. C to the fourth divided by c squared is just c squared. You can always do this on the side of your paper. You could always do this. So don't be guessing and stuff in here just because you don't want to rewrite this. If I take negative 4c cubed divided by 2c squared, that's negative 2c. Again, if I divide that, if I show you, which I'm not going to do this on all the problems, negative 4 divided by 2 is negative 2. C cubed divided by c squared is just c. And then if I take 6c squared divided by 2c squared, the c squareds cancel out, and all I have left is 3. So this, or these two, are the two pieces that multiply together to get this. Or, in other words, this is how to factor using the greatest common factor. All right, let's keep going. Number 4. All right, I get more variables, I get more stuff like that. But the first thing you want to do is focus on your coefficients. I have a 1 here, I have a negative 2 here, and I have a 1 here. I can't factor out anything other than other than a 1. So in this particular problem, I don't have any numbers to factor out. Is that a problem? No, you just keep working. The next thing is x. Remember, whenever you have variables, go find the one with the smallest exponent. X to the first, x squared, x to the first. So what am I going to pull out? An x to the first. I got y to the first, y to the first, y cubed. So what am I going to pull out? A y to the first. Write that next to an empty set of parentheses. Now I have to divide xy, 2x squared y, and xy cubed all by this. And I'm not going to have to rewrite that because I know how to do it in my head. xy divided by xy is 1. A lot of people mess up on those. Whenever you have the same thing divided by itself, you don't cross it out and say 0. It is 1 whenever you're dividing. I spent a lot of time talking about that this year. Negative 2x squared y is going to give you negative 2x. And then xy cubed divided by xy is just going to give you a positive y squared. Check it out. If you foil this, not foil, but distribute this back out, you'll see that we get the same original problem. And that's a way to check all of these. Multiply them back out. Distributive property. See if you get the regular or original problem. And that's how you know you've done it right. If you need to see more, come holler at me in tutoring. All right, number 5. Let's try this last one. I'm asking you to factor. And many times they don't ask you to factor using greatest common factors. They just say factor. So you need to know to always start your factoring using the greatest common factor step, because there are going to be different types of factoring going on. All right, let's keep the same procedure. We got a 10, starting with our coefficients, negative 5, and a 15. What's the biggest number that you can divide out of each one of those? All right, that would be a 5. All right, so we're going down the list. Next is W. W squared. What's the rule? Always pick the one with the smallest exponent, so I'm pulling out a W. Z squared, z to the first power, z to the first power, that's a z as well. I don't know why I didn't put a little line there. Anyway, so I'm going to take z to the first power because you always take out the one with the smallest exponents. Write that next to an empty set of parentheses. Now, if I divide this first term by this right here, I'll get 2z. 5 divided by, and 10 divided by 5 is 2. The w's cancel out. Z squared divided by z to the first power is 2z. If I divide this right here, this one right here, to the middle term, by this, what do we get? That's right, negative 1. I know you said negative 1 because I can read your mind. Because it's the same thing, divided by itself is 1, but that's a negative, so that's why it's negative 1. 15w squared divided by this, 15 divided by 5 is 3. W squared divided by W is W, and the Z's cancel out. This is your answer. All right? With the time I have left, I just want to do this just to show you that this is true. I want to go in reverse. Now, in class we talked about it. Multiplication undoes or inverses division, and division is the inverse of multiplication. So what I just did was broke this down, in other words, divide. So if I multiply, I should go right back. So I should get back what I started. So let's multiply. Distributive property. 5wz times this, 5 times 2 is 10. wz times z is z squared. All right? 5wz times -1 is -5wz. It doesn't do anything but change the sign. 5wz times 3w. 5 times 3 is 15. W times W is W squared. And Z times 1, I guess, is just Z. Now, is this the same as that? Yes, it is. In fact, if you go back to each one of these problems on here and do what I just did, do the distributive property and check to see if these multiply back, you'll get the same answer. So these are inverses of one another. Factoring is like dividing, and of course multiplying, they are inverses of one another. So always look for the greatest common factor. The reason why we start in common factor first is because this type of factoring, it should be the first thing that you do on every single problem that requires that you factor. Always look for greatest common factor. All right? Now, I have to do this because I'm a math teacher, and this is what we do. We make up stuff on the fly. If I had this problem right here, look at number 6 here. And I ask you to factor using the greatest common factor here. The first thing you do is start off with your numbers. I have a 1 here, I have a 6 here, and I have a -2 here. You would consider that I could take out a 2 because of those two, but you can't because there is a 1 here. You can't take out a 2 or a 3 or something like that if you can't here. So the next thing is the variables, x and x. X squared and x. You could take out an x from those two, but notice that the 2 doesn't have an x. So this is an example of a problem that you cannot factor out a greatest common factor on. It can maybe factor some other way. We haven't learned it yet. I'm not going to talk about another way that possibly it could factor. But as far as what we've been working out on here, you cannot factor anything other than a 1. Now, if this problem started out like this, normally we do not want our leading term, our highest exponent term, to be negative. And so in this case, the only thing you would be able to do is factor out a -1, which simply changes the sign of everything on the inside. Now, you can't just get rid of it. It stays out here. But we will sometimes factor out a -1, okay? When do we do that? Whenever our leading coefficient is negative. And if there was something I could factor out, like a like a 2 or a 2x or something, that would have came out negative in this situation if our leading term was negative. Other than that, guys, we never factor out a 1, or we just couldn't factor that in the original problem I wrote down. All right, that's all I got.